Check. Okay. Bismillahirrahmanirrahim. Good afternoon, dear participants. Welcome to Askbeard Berkah Konsultan. Today, we would like to talk about blue carbon mapping using InVEST and quantum GIS software. Okay, I will share the screen of my slides. Okay, my name is Azhar Hadian. I am from Askbeard Berkah Consulting. And this is my LinkedIn, and this is my Zuckerpass account. Okay, before we'll talk about blue carbon, the reason why we learn about carbons, at least there are 3 reasons why do we learn carbon today. We are now, as humans, living on this earth cannot be aparted from the existence of the carbons. First, as we know that human body contains approximately 18.5% of carbon, especially on the part of muscles, tissues, bone, and in the mind part, it is called as DNA. DNA contains 5 sugar carbons that if the carbon is not complete, it will be the genetic mutations. What will happen after the genetic mutations? The baby born will be dead. Or if the baby born, it will have some health problems. Second, why do we learn carbon? The reason is we eat some food. Food contains carbohydrates, proteins, and also fat. In carbohydrates, there is approximately 40% of carbon, and in the proteins, there is approximately 55% of carbons, and in the fat, approximately contains 75% until 79% of carbon. So our food contains carbon. Then today, when we are attending the carbon training, we also emit carbon, especially for scoop 2 carbons. Why? Because we burn the fossil indirectly. We use the electricity to support our activities today. So our life cannot apart from carbon. That is the reasons of our life. So we need carbon in our daily life. Next, we know that the pictures describe about the carbon cycle. The carbon cycle is similar with the energy concepts. The energy concepts is energy amount is always same by time. Energy just changes from one form to another form. For instance, when we are eating, we take some energy to our body, and the energy will be changed to movement. And when we move, we need energy. Or if we are not moving, the energy will change to the fat. Yes, so there is no burning in our body, and the energy change to be fat. So we say some people having obesity, overweight, it is due to unchanged energy. Yeah, so the energy stored as fat. According to MIT Climate, there are 350 billion tons of carbon dioxide circulating in this year every year. The problem is when the carbon emission is higher than the carbon stock or carbon sequestrations. So the climate mitigations is to balance between the carbon emissions and also the carbon sequestrations. So what's happened when the amount of carbon emissions is higher to the carbon sequestrations, it will lead to the global warming. And the results of the global warming is climate change. Climate change is not only happening today, but it has happened several times on this earth. Based on the history from some literatures, it is proved that there are at least 5 times of ice age on this earth. And the ice age changed to the other age and change again to the ice age. It's signs of the climate change. So climate is always changing. Every time climate is changing because the conditions of temperature is changing every time. And today is the world's climate change. Yeah, since the James Watt found steam engine, it leads to the revolutionary industry in Europe, especially in England and also in France. The results of the revolutionary industry on 18th century leads to the decreasing of the biodiversity of the butterfly. Why decreasing? Because the conditions of air was not good. There was air pollution and there was the greenhouse gas emission. The butterfly in London before revolutionary industry was various. There are so many species of butterfly, but after the revolutionary industries, the butterfly is only the black butterfly. It is the signal of the environmental change. Yes, as we know that wildlife is a sign, can be a sign. Wildlife, yes, bird and many other animals can be a sign of environmental change. Okay, so today the increasing of the air temperature is more than 100 years before. Okay, so what is the correlations between carbon dioxide and also the climate change? We know the concepts of carbon dioxide as the concepts of the carbohydrates in our body. Maybe we know the diabetics disease, diabetics type 1, type 2, type 1.5, and other types of diabetes. Why it happens? Because the high amount of sugar cannot be trapped by insulin. Yes, so the sugar emits our body. In our blood flow, there are much sugar. Yes, so to normalize the diabetics, it is depends on the type of diabetics. For instance, diabetes type 1, the patient should input insulin, but for diabetic types 2, the patients must control their daily consumptions, to minimize the amount of carbohydrates enter to the body. Yes, the concept is like the CO2 concepts. Yes, we know the diabetes is the mother of the disease, and also the higher content, the higher CO2 in atmosphere that leads to the climate change make some complications in our nature. How it correlates? If we know in the early of 19th century was the beginning of the emergence of the science related to climate change. It is due to the occurrence of global warming. Yes, because the revolutionary industries. And then in the 1820, French mathematicians put forward a theory regarding the greenhouse gas effect. The greenhouse gas effect is like when a people enter to the greenhouse. What's happening in the greenhouse? Greenhouse is usually built in the winter country, the country with 5 seasons. Sorry, 4 seasons, and it can make the conditions of the room warmer. Yes, especially in the winter. The condition of Earth is like that, and In 1850, Unique 40 discovered that carbon dioxide, it is the answers, the carbon dioxide may increase the environmental temperature. We may read her papers on circumstance affecting the heat of the sunrise. Then the John Tyndall in 1859 states the transmission of radiant heat through gaseous bodies states that carbon dioxide is able to absorb solar radiations. So the carbon dioxide may absorb solar radiation. And Arrhenius conclude that to reduce the Earth's temperature is by reducing the amount of carbon dioxide on atmosphere. So the key is carbon dioxide. It is same as the concept of diabetics. The people with diabetics has a huge amount of the sugar on his bloodstream. So as a medical, usually some doctors, some nutritionists offer them to do the ketogenic diet or low carb diet to prevent the spike of the blood sugars. It is SMS, the concepts of carbon dioxide, the dioxide emission today. Yes. So to reduce the emission means reducing or decreasing the air temperature. Okay. Next. Okay, what are the impact of climate change? The impact of climate change is first global temperatures have risen by 2 Celsius degree. What is the impact of the increasing of 2 Celsius degree of the global temperatures? It may result the ice melting in Antarctic and also in Greenland. Yes. So what happens if the ice melting? The sea level will be increased. The sea level increase by 20 centimeters every year until now. So some islands will be sinked. And the sea surface temperature, so the global temperatures also change the sea surface temperatures. It will disrupt the life and the biodiversity under the water. Yes. Besides for impacts, there are so many other impacts because of the climate change, especially to the agriculture, yes, to health sectors, the economic sectors, and many other sectors due to the climate change. So, after we understand the cause of the climate change that is caused by the higher amount of greenhouse gas emissions, especially carbon, we have to understand three terms. The first is carbon stock, second is carbon sequestrations, and the third is carbon emissions. What is the difference before those terms? It is like when we have money. We save the money in our bank account. It means carbon stock. We save it by months, by years, yes, until maybe we have thousands of dollars or maybe million of dollars. Now it is called carbon stock. But what is carbon sequestration? Carbon sequestration is the amount of money we earn per day, maybe per week or per month. Yeah, if we work as the permanent worker, we will achieve the monthly earning. Yeah, it is called as carbon sequestrations. Yes. For instance, our saving is maybe $1,000, but per month we get $500. Now, $500 per month is called as carbon sequestrations. Yes. If all of the money that we earn, we save it all, it will be 1,500 $1,500. So what is the carbon emission? Well, carbon emission is the money we spend. Yes, the money we spend. Yes. Now, that is the concepts of carbon sequestration, carbon stock, and also the carbon emission. Now, so the carbon stock is usually stored uh, above above ground biomass. Yes, above ground biomass is like on the tree, on the dead parts, or the others. Yes, or litters, many others uh, on the ground. But the soil organic matter usually called as below ground biomass. Yes, it is some other forms like plants, animals, and humans that is decomposites under the ground. So what might cause the difference quantities of the carbon stocks of the land use? There are many factors. The first is vegetation factors. Every species of tree, they have the ability to sequester and also the stock of the carbons differently. Yeah, there are various different uh, ability to stock and also sequester carbon. Okay, then the number of trees, and then also the density of trees. The next factor is environmental factors, like photosynthesis, growth, water content, fertility, temperature, and others. So the questions is, does climate change affect the carbon stock? Because climate change may change the temperature. And the higher temperature will make the trees become stressed. The stressful tree may reduce the ability the of photosynthesis. So the carbon sequestration will be lower, then the carbon stock will be lower. Yeah. So this is a hypothesis. Okay. Next. Okay. Then the carbon sequestrations. Yes, carbon sequestration. I have told it. Yes. It is like the money we earn per month, and carbon emission is like money we spend. And carbon emissions usually is from the fossil fuels combustions and cement productions, and usually it is from land use change. Yes, from the vegetation to non-vegetations, it will lead to carbon emissions. Yes. How about our breath? We are breathing today, and we release carbon dioxide. Is it called as carbon emission or not? According to MIT article I have ever read, that it is not carbon emissions because the amount is not as many as the carbon emissions from fossil fuels, from land use change. Yes, yes. Our breath maybe release the carbon, but it is not the carbon emissions. Okay. Usually, carbon emissions is called carbon footprint, and when we talk about carbon footprint, usually we'll talk about carbon emissions. Today, we just only talk about carbon stock, yeah, and also the carbon sequestrations. So what is the difference in measuring it? Usually carbon stock is in ton carbon. Yes, ton carbon, ton C. And the carbon sequestration is in CO2. So if we have 100 carbon stock, yes, to convert to carbon sequestration, it must time with 3.67. 3.67 point times 100. So our carbon sequestration is 367. Yes, these carbon sequestrations to convert it. Okay, next we would like to talk about the blue carbon. What is the blue carbon? We know the blue usually represents the water. So blue carbon is the carbon sequestered within the mangrove forest ecosystem. But it is not only the mangrove forest ecosystems. Usually the seagrass ecosystems and also the tidal marshes ecosystem is usually called as the blue carbon ecosystem. Yes. So this carbon is distributed across a variety of biological and environmental compartments, including soil matrix, vegetative biomass, root system, and necromass. Yes. So such the positions undergoes the critical ecological functions of mangrove forest in carbon cycling and storage. Yeah, so the blue carbons ecosystems usually contain mangrove, tidal marshes, and seagrass meadows. Okay, the comparison between the stock or the storage of the blue carbon and also the terrestrial carbon. Usually the blue carbon storage is higher than the terrestrial carbon storage. Why? Yeah, especially in the soil organic carbon. So when we live in tropical countries, especially maybe in Indonesia, Philippines, Malaysia, yeah, and many other of tropical countries, the protection of the blue carbon ecosystem is important. Why? Yes, because the blue carbon ecosystem has a crucial role in saving and storing carbon because the conditions of the blue carbon ecosystem is anaerobic conditions. It will delay the decomposition of the carbon. So the carbon is hard to release to the atmosphere. The carbon is locked under the soil. Yes, by years, and years, until 100 years, 1,000 years under the soil. Except there is a land cover change or a land fire, it will be different. It will be different things. But if we let the mangrove grow, if we let the seagrass grow, it will save the carbon for long times due to the anaerobic conditions. Yes. So the reason why the blue carbon is much higher than the terrestrial carbon because the anaerobic conditions. Yes, it is contrast with the carbon storage on the upland soil on the terrestrials. Usually, if we only plant the tree, the aerobic microbial oxidations of organic carbons happen. Yes. So if we let the tree grow, the carbon dioxide also released to the atmosphere. Yes. How if we do the land clearing and also there are met carbon emissions there. The other reasons is we have to understand the concepts of carbon mechanisms. Sorry. Okay, the carbon mechanisms here. There are two mechanisms. The first is allochthonous, and the second is autochthonous carbon. What is the difference between it? Autochthonous carbons is the carbon is stored on the place the carbon storing. We see the picture here. Allochthonous is only stored here, but in the in the sea, in the ocean, there is tidal waves, yes, and coastal currents. It will make the sediments move from one place to another place, yes, and it will uh, accumulate on one place, yeah. Such as here, maybe the sediments stay here, but due to the tidal waves, the coastal currents, it will move to the other part, maybe to here, and it will happen uh, by years, yes, 100 years, even 1,000 years. So what will happen if the condition is anaerobic and the movement is almost daily, yes, and it will be the accumulations of the sediments. So it will increase the carbon stored. So that is the reasons why the blue carbon is higher than the terrestrial carbon. Yes, there are two reasons. The first is due to the anaerobic conditions. Second, due to the blue carbon mechanisms itself, especially on the allochthonous mechanisms. Okay, carbon emission from mangrove. Yes, so especially in our country, in my country, Indonesia, it has been the loss of mangrove from 2007 to 2009 for approximately 3 million hectares. Yes. So it leads to the global carbon emissions because Indonesia is containing 23% of the mangrove in the world. Yes. Now, so it will lead to the carbon emissions. Not only carbon. If the mangrove change to another land use, or we we call it land cover change to another land use, especially to the built land or the tourism land, yes, or many other non-vegetation land, it will lead to the carbon emissions and also the methane emissions. Yes, the two kinds of the greenhouse gas emissions. Okay. Okay. Mangrove and seagrass, which is more effective in carbon storage. It is based on the Ramsar data that the carbon storage of mangrove is much higher than the seagrass. Why? Because the complexity of mangrove roots. We know the mangrove roots is complex. If we see the mangrove roots is complex, then the seagrass roots maybe. Yes. Okay. The highlights of uh, complex root leads to the highlights of the sedimentation depositions. The sediment depositions, as I stated before, contains much carbon stored, and the condition is anaerobic. So the mangrove stores much carbon dioxide. Yes. So the mangrove ecosystems may reduce the global emissions, may reduce the carbon global emissions. Okay. Before we practicing quantum GIS and InVEST software, if you have any questions, uh, let's chat or ask directly. Yes, phytoplankton. Okay, phytoplankton is, oh yes. Listen. Phytoplankton can also absorb the carbon, but it is not as large as mangrove. If we use Earth engine, yeah, and the phytoplankton also contains chlorophyll, especially chlorophyll A or B. It will be counted the carbon amount, but the amount is not as higher than the mangrove ecosystems. Next is about economic valuations. Yes, economic valuations. Well, okay. For economic valuation, InVEST software can also help for valuing the economics, but the economic valuation method uh, today we are not delivering the method because economic valuation method is complex. Yeah, there are so many methods. And there is a contingent method, hedonic price method, yes, to a market value method, yes, and many others, yeah, many other methods. But the price today that we use, the price of carbon, yes, if we would like to insert the price, yes, but the price today we use the price rupiah price, yeah, Indonesian currency as much as 30,000 rupiah per ton, yes, for Indonesian carbon. Maybe any other questions? Okay, reduce the carbon footprint. Okay, yes, we should reduce our carbon footprint, but today maybe it is hard, yes, because we are full using of the technology, yes. Even today we use AI, ChatGPT, yes, or other AI that leads to the scope to emissions, yes, because some theory says that using AI, even we use cryptocurrency, maybe it leads to the much higher carbon footprint. Yeah. Okay. Okay. Today we will talk from the mangrove ecosystems. Yes. Why do we only from the mangrove ecosystem? Yeah, because mangrove ecosystems is the large ecosystems in our sample data. Yes. We take the sample on uh, Aussie Island, yeah, Moluccas. Maybe some participants from Philippines know Moluccas. Yes, this is the if you go to south, yeah, from Sulawesi, Celebes, and from Sulawesi you uh, can go to Moluccas. yes, or Maluku, yes. Okay, I have sent the data, yes, to on the WhatsApp, yes. The admin has sent the data from WhatsApp. Okay, the software you use today, there are two softwares. First is Quantum GIS, second is InVEST, yes. Why do we use it? Yeah, usually because we are mapping the mangrove, we use Quantum GIS, and to calculate the carbon storage, we use the InVEST software. Okay. Okay, maybe you open the data here. I have sent the border data, the physical data, and other data. Okay, maybe some of us know that the image, yeah, the satellite imagery is comes from Landsat image. But how do we extract the image? Yes, I would like to tell it first to know how to extract the image. To extract the image, we have to visit the website artexplorer.gs.gov. Okay, I will share it to uh, Zoom chat. Okay, next. Okay, to choose the patrol, yes. What is the patrol? Patrol is the code of our data collections. The patrol here is 109 and 62. Yeah. How do we know it? Yeah, we have to find on our by Googling. So there's patrol Indonesia. Today, our patrol is in Aussie Island, Moluccas. Where is Aussie Island? Yeah, Aussie Island is here. Yes, this is a small island but has huge amount of mangrove. Yes, on 109 and 62. But before we find the data on Landsat, we have to log in. Yes, if we don't have the account, we have to register it. Okay, select a geocoding method. We select patrol. We enter the patrol 109 and 62. We click show. Okay. This is Aussie Island. Then we input the uh, time, the month, day, and year. For instance, month 1, day 1, 2024 until month 12. So click datasets. Okay. We have to extract or download band 5, 6, and 3. Why do we only choose 3 bands? Yeah, because it will be used on our index, EMI, Enhanced Mangrove Index. Yes, you may see the paper, you may read the paper here. Yes, from Science Direct for the reasons why we're using the index. Yes, yes. Now you may read the paper. Okay. Next, click Landsat. Landsat collection 2, level 2. Landsat 8, 9, 8 to 9. Then click the results. We should find the free cloud, yes, with the clear cloud satellite imagery. So it will be hard if we have the cloudy data. It will be hard to analyze. For instance, we choose here. Okay, okay. Previous, maybe on June or July. Okay, maybe this data is good. Oh, yes, so many clouds, yes. Previous. Okay, this data is good, maybe. Okay, for this area is good. Just download it. Loading options. Product options. Download band 3, 5, and 6. Download it. Click here, and here. So it will be here. Yeah. So that is how to get the data. Then we may open our Quantum GIS. Maybe if you are the first time to use the GIS, Quantum GIS, you may find QGIS desktop. Click here. Yes. Until this. Okay. Okay. Any questions? Okay. If there's no questions, I will continue. This training is recorded, so I will share it. Yes, the admin will share it. Yeah, you may ask the admin if you will get if you want to the certificate, and also to get the recording. Okay, if your display of your QGIS like this, yes, you have to click right here. Then you click layer panel. Why must it be excised? It is to insert the data. Yes. To show the data. To insert the data, you have to click right and click manage layer toolbars. It will be difficult if we cannot insert the data. Yes, like it. The data we use is the raster data. Yeah. So the data in spatial analysis usually vector and raster. What is different? Raster data is built by the pixels. Click the raster data. Click here. Click data and change it to GeoTIFF, because if you only choose the all files, maybe you will be curious. Yes, you'll be confused. Just convert it to GeoTIFF. Okay, first is like for 2019. Yes, 2019 you may see here 2019. 2019 years. Click open. Click add. Okay. So then we use raster calculator to insert the formula. What is the formula here? Yes, the formula is near or band 5 minus band 6 per band 5 plus band 3. Yes. Yeah, what is the band 5, band 6, band 3? You may read here. Okay. So the function of the index is to classify mangrove and non-mangrove. Okay. We insert the formula here. Band 5 minus band 6 per band 5 plus band 6. Okay. Output layer. We may create a new file. Results. New file here. Click EMI 2019. Save. Then click OK. Okay. Next is for next year's. Yeah. We just remove the image, the 2019 image. We enter to new image for 2024. Oke, klik ya. Klik raster calculator. Band 5 plus 3. EMI 2024. Klik right. Klik OK. Okay. There are two data. Remove unusable data. Okay. So to classify it, you have to click by the border of the area that we use. Click add vector layer. The vector layer is usually in a shapefile format. If the format is like this, you may change it to as shape files, then click the border. The border is on Aussie Island, on Teluk Kawa in Molucas. It contains huge amount of mangrove. Sorry. Okay. You may see the best maps. Yes, it contains a huge amount of mangrove here. Yes. How to appear to the best maps? To insert the best maps, you have to click plugins, manage and install plugins. Then you may select HCMGs and then you install it. Yes. Okay. Okay, then we may classify it as 3 classifications. So do we know if the area is only 3? Yes, because it is based on the secondary data, yes, or literature study, yes. Here I use the secondary data. This is for from my data analysis, yes. For the index under 0.1 is called a shrub. 0.1 until 0.3 is called dry forest, and up then 0.3 is mangrove. Okay. We have to click first for the EMI index. Click raster conversion, extractions, click raster by max layer. Click EMI 2019, max layer border. CRS target. What is the CRS target? That is the coordinate reference of the area. Yes. The area is on 52 south. How do we know it? We may click ETM zone Indonesia. Yes, ini the country ETM zone and the Aussie Island on the Moluccas is located here. Okay. EMI, then save it, save to file. Click here, EMA, Aussie 2019. Also for EMI here, max layer with the border, EMI, OC 2024. Save and run. Okay. Next, we have to classify the value. The value has not been classified. Yes. To it classify per lane cover. Okay, we remove the other EMI. We focusing on EMI that has been cut with the border. Okay, to reclassify it, we may select processing, then we select toolbox. Click here, reclassify by table. Enter the data. Yes, data refers to this. We just enter the value. Number 1 is for shrubs, number 2 is for dry forest, and number 3 is for mangrove. Then click OK. So the range boundary is like this because it is under 0.1. Use no data, then we reclassified it as land class. Land 20. Okay, click run. Then for it is same classes. We'll click here. Land 2024. Click save. Click run. Question. Okay, thanks for sharing, Mr. Kendall Bolanio. Okay. Okay, we remove this. Okay. Then we enter to the InVEST software. Okay, to open the InVEST software, I hope you have installed this software. We may click InVEST, InVEST Workbench. Yes, so it will be like this. For the appearance, click coastal blue carbon. What the data do we need? First, the workspace, file suffix, line covers, and many others. So we need two different line covers here. Why? Okay. We can read this. Yes. It explains the data that we need for the blue carbon data. Yeah. We just read this. And also, the format of the data can be downloaded from here. Okay. You might download the coastal blue carbon zips and yes. We have to process the raster image first. Okay. The data of the Excels will be here. Okay. What are the data? We may click coastal blue carbon. Inputs data. Snapshots data, yes. And many others data. Okay, I have sent the data. Snapshot data. Okay. We have to name it as the data name. For instance here, the data that we enter is line 2019 and line 2024. 24, yes. Okay. You have to change the name line 20 dot div. Don't forget dot div. And this line dot div. Okay. Then you have to save as here. Why here? Because the raster is here. Yes. So we have to save here on CSV format. Click save. Yes. Then the other data that must be excised is the biophysical table data. Yes, the physical table data is very, sorry. Okay, it has been opened. So the data is contain shrub, dry forest, and also mangrove. Okay, what must we fill here? We have to input the data for the biomass initial soils and other data. How do we know it? Yes, because we are know it from here. What must we enter? This is the guidance. Yes. Okay. So the data that I got here is from referring from the data from the Ministry of Forestry. Yes. So if you have the data from your country or many other literatures, you may fill it. Okay. Okay, the data here, yes. And now we are today practicing. Yes, this is not all data I got from literature. Yes, there are some example data or dummy data. Yes, why? Because we have to have find the literature, or we have to take from the field for the data. The data that I got is only here. Yeah, but if it is not filled, the result will not be good. Yeah, it will be zero result. So we have to fulfill all of the data. Yes, to fulfill it, you have to read the guidance. Not all data in ton per year, ton per hectare per year, but they are the ratio data. Yeah, so surface data and managed data. Yes, maybe you have to find some literatures if you are doing the research. Today we are just doing the practice. Yes, some of data I got from literature and some of data I create by my own self. Yes, because today is still practicing. But for the research, you have to create your own data based on the letter or based on the field study. Okay, we have to save it in CSV. So the format is always in CSV. Okay, yes, what is? Okay. Okay, maybe. Okay, we will share the recording, yes. Okay. Next is transition data. What is transition data? Transition data means uh, the line cover data. Yes, the line cover change data. Yeah, the transition data. Itu istilah bahasa. Shrub. Yes, we have to make it same. Shrub the forest mangrove. Mangrove. Okay. So what is NCC accumulations might impact and many other impacts? Yes, that is the terms. You may read here from the guidance also. No. Accumulation of state cover accumulation. So accumulations means the carbon increasing. Yes, no change. There is no change of the data. Yes, high impact disrupt, high carbon disturbance rate, low carbon disturbance rate, and many other terms. So why here shrub to shrub there is no carbon change. Shrub to dry forest uh, accumulations because shrub contains lower uh, carbon carbon stock in dry forest, and shrub to mangrove accumulations. Yes. So it is based on the theory, or maybe if you understand about the land use and cover, you may insert uh, the terms. So must the terms like this? Yes. InVEST software, unfortunately, is very sensitive software. If we are wrong, although only wrong entering an alphabet, a comma, or a point, it will be error. Yes, that is the disadvantage of the software, the weakness of the software. Okay. Yeah, high impact disrupt and other. Yes. Then we save it, save as results. Then we have to save it in CSV format. Yes. Okay. Take it on 2019. 2019, yes. Okay. Okay. Click workspace results. Click here. Click new. Okay. So here we are trying to understand about the carbon change. So when we are talking about the land use change, usually the data taken is from the initial year. For instance, the the land use change from 2020 to 2025, the data usually taken is from 2020. Yes, because the future year is the result of the land cover or land use change before. Click try, select folder, uh, text years. Maybe we blue carbon. Click land cover snapshot. Okay. The physical table. Land cover transition table. Okay, the analysis here, it means that the conditions of carbon that will be predicted, maybe 10 years later, 2034. Yes. If you want to valuing the economic, you may run it. If you're not, just not putting it. Yes. Okay, questions. Okay, click run. Okay, open our workspace. Yes. Then we open again our quantum GIS. Output, carbon accumulations, yes. Maybe blue carbon stock. Yeah. We compare some data here. Carbon stock. Now, this is different carbon stocks by years. Yes. You may compare the data. Sorry, it's voice. Okay, okay. Please mute the Musa Ibrahim. Okay, okay. I will mute. Okay. Okay, yeah. And gain the carbon stock at 2034. Okay. Now, this is the conditions of the carbon stocks. Okay. Maybe we may lay out with the map. And change it to blue. Yes. So the carbon stock here, the carbon stock here will be higher and higher if there is no land clearing. Yes, because we are not entering the land clearing variables. Yes. Okay. Why it will be higher? Because there is the accumulations from shrub to dry forest and shrub to mangrove. Yes. How do we know it? Okay. Uh, maybe how to know it? Jadi, sorry. Okay. I would like to explain it before. We may use small use to identify the land use change. Manage install plugin. We may use small use. Yes, install it. Yes, in the installation. Then click raster mollusc. Yes, there is a change here from number one. Number one means yes here shrub to shrub, shrub to dry forest, yes, shrub to dry forest, and shrub to mangrove, yes. And next is from the forest to shrub and the others explanations. Okay. The change to the mangrove may higher the uh, content of the carbon stock. Okay. We may click the new plan layout. Click layout. Then we may layout for 3 years. Log map. Questions? Yes, sure, on the specified area. Okay, okay. So is then okay, okay. Now clears and we change the scale. Number 2. Number 3. Okay. Carbon amount will be different. Right? Simple fill color. Boolean fill, colorant, and blues. And rotate it to 200 and sorry. Okay. Patience. Next is enter the amount of the carbon. 84 to 83, sorry. 2 200 and yeah. Questions? With the pleasure. Okay. Next. is okay. 529 and also 100, 1000. Okay, last is about same, and next is okay. Okay, then we input the year. This 2019. Okay, 20. Okay, okay. It is the below carbon data. Yes, maybe we can make the title. Okay, okay. Click font. Okay, then maybe we can save it as the image. Okay. Besides that, you maybe enter the other data. Yes, from our results, there are carbon emissions, yes, sequestrations. Yeah, maybe you have to enter in to make the data more accurate. Okay, questions? Maybe your PC is Mac or what? Yes. In the software, InVEST software, download. Maybe you may try older and development versions. Yes, there are many versions here. Okay. Any other questions? Maybe that is uh, the end of our course. Okay. Other questions? Okay. Accuracy assessment maybe okay. The accuracy assessments is done with by validating to the fields. Yes. How to do that? Yeah. Okay. Accuracy assessment. Maybe we can maybe choose here. At 2024 carbon. We have to create new shape file. File name. Accuracy maybe yeah. I will accuracy. Usually geometry type maybe point. Okay. We check to the fields. Maybe number one, number two, yes, number three. Maybe there are three uh, points, yes. Actually, there's not three, but for the example, only three. Create the X and a comma. Then you may create the Y. Then you open field calculator, apply casting field X and Y. Okay, you may save it. Okay. After that, you have to convert it to save speedrun. Convert to GPX. We enter it to our GPS for tracking. Quick survey. Then yes, yes. And we may click OK. When we just tracking on our GPS. This is to create the accuracy. But we have to know how many this is the high carbon is the high carbons, high carbon area, because the color is blue. Yes, the dark blue. Any questions? The accuracy assessments is only for the recent years. Yes, for the initial years, for the years before and the forecasted years, we may use the results from current years and we forecast for the next years. Besides this, we may also do the accuracy assessment using the Google satellite. You have to check here. Yes. For instance, for the carbon stock with the higher carbon stock, carbon stock area, it's a two. This is the uh, full of mangrove or full of forest. Yes, this is what this area with the high carbon for years 2024. This area the dark blue area is high density mangrove. The indicators. Usually the area with the high carbon, it is usually high the contains high sedimentations. Yes, high mood. Yes, yes. We will share the YouTube usually, but we have also count the diameter of the mangrove itself and also the components of above ground biomass. Okay, because it is, yes, every years 2019, 2024, it has the different data from our analysis from uh InVEST. So we make the range based on the data. We create the data based on a range resulted from InVEST software. Okay, I think it is all from my presentations. Maybe before we close the presentations, I would like to say thank you very much for your attentions. Before we close, maybe you may turn on your camera for documentations. Okay, let's turn on the camera for the documentation. Okay, 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 okay. Okay, next. Okay, thank you very much. Maybe next time we will meet again in on other training. I would like to close the sessions. Good afternoon, and thank you very much for your attentions.